Hi everyone. So in the previous video we were talking about the idea of acids. We did talk about the fact that acids produce H plus ions, which is something we need to remember. Then we do know that acids can react with metals. When they react with metals, they displace the H and we get a hydrogen gas molecule. So we get H2 when acids are reacting with pure metals, and they obviously make a salt. So the salt depends on which kind of metal we are using. Then we have acids reacting with metal carbonates. So they produce carbon dioxide gas in that case, because whenever it's a carbonate, which means it's a CO3, so the CO3 gives you CO2, which comes out as a product, and it gives you one O, which goes with the H to make the water molecule. So the oxygen goes with the H to make water molecule. The metallic part goes with the non-metallic part from the acid to give you the salt. And depending on what kind of metal carbonate we are using, what kind of acid we are using, we get a very specific salt. But the H2O and the CO2 are very common, so these products remain the same. In today's session, we are going to be talking about the idea of bases. So we'll see what bases are, because acids react with bases, and we do know that we're going to be calling it neutralization. So we'll see what bases are in this video, and we'll see what is the term alkali all about. So bases, it's a larger term. So when we talk about bases, it's a bigger term over here. Let's say, so bases are any substance that neutralize an acid. So they are substances that neutralize an acid. When a base is soluble in water and it produces OH minus ions, so if a base is soluble in water and it produces OH minus ions, in that particular case we call it alkali. So alkalis are a smaller term within the larger umbrella of bases. So an alkali is a base. It's within the base, so it is a base obviously that is soluble in water and produces OH minus ions. It produces OH minus ions. Bases are possibly soluble in water. If they are soluble in water, we call them alkalis. They might not be soluble in water. So if they are not soluble in water, we call them insoluble metal oxides. So it could be insoluble metal oxide, for example, magnesium oxide, calcium oxide, zinc oxide, copper oxide, iron 2 oxide, iron 3 oxide, maybe silver oxide, etc. But if it's an alkali, it has to be water soluble. An example of alkalis, we have lithium hydroxide, we have sodium hydroxide, we have potassium hydroxide, nothing else. There are no other examples. There's one more that we'll talk about later, but we don't have alkalis of magnesium or calcium or maybe copper. They don't make alkalis. So we have 3 alkalis right now, and we have metal oxides which are insoluble, so these are bases. At the end of the day, they both react with acids and they both neutralize acids to make salt obviously and water. So when we talk about acids with alkalis, it's again a partner changing reaction. So for example, you have HCl, which is an acid, reacting with NaOH, which is an alkali. They are both water soluble, so they are both in aqueous solutions. H plus has a charge of obviously +1. Cl is definitely a -1. Sodium is group 1 element, so it has a charge of +1. OH has a charge of -1. OH is also known as hydroxide, so one thing has to be very sure. OH is equals to the hydroxide ion, because obviously it has a hydrogen, oxygen, and it has a -1 charge. So OH looks something like this. It has these 2 atoms. It has OH, and it's a combined charge of -1. It's OH -1. So they changed their partners over here. The H goes with the OH, giving you a water molecule. The Na goes with the Cl, giving you NaCl as a salt. Water is obviously liquid, and NaCl comes out as an aqueous solution of a salt. Let's try one more example over here so we can be having any other alkali. For example, we have KOH, which might be reacting with perhaps H2SO4. Now we do know that H plus is obviously a positive cation. Sulfate has a -2 charge. Potassium is group 1 element, so has a charge of +1. OH is definitely a -1. What are the products? What are the combinations? The H would want to go with the OH part, so it will make water molecules. Since you have to balance it, we'll balance it later once the products are done. The SO4 goes with the K and it gives you potassium sulfate. So K, SO4, but remember one thing, potassium is group 1 with a charge of +1. SO4 has a charge of -2. I'm not writing the signs. I don't need the signs. What I need is the number. So potassium has a +1 charge, sulfate has a -2 charge. The charge of SO4, which is 2, comes with the K, and the charge of K, which is 1, goes with the SO4. So we don't have to write the 1 obviously around the sulfate, but the formula turns out to be K2SO4. So it becomes K2SO4. I cancel the rough work. Once I'm done with the formula, I might want to cancel the rough work. So this is the product. We get potassium sulfate as an aqueous salt, and we get obviously water as a liquid product. Let's have one more example before we get done with this. Maybe we have one more alkali. Remember I mentioned about that. So that is ammonium hydroxide. Ammonium means NH4. So it is ammonium hydroxide, which is again the fourth alkali. We don't have any other alkalis. We have LiOH, we have NaOH, KOH, and NH4OH. These are the only possible alkalis. Let's take nitric acid with this one. Obviously H plus has a charge of +1, NO3 is -1, OH is -1, so obviously NH4 should be +1. Let's move it a little at the bottom so we can show the change of charges. H plus goes with the OH minus, it gives you water. So obviously one of the products we get out of the neutralization over here is the H and OH combining to give you water molecule. What else do we get is NH4 going out with the NO3 part. So with water, NH4 goes out with the NO3 part, and this is the next product that you get. So these are the two products over here. I don't know why I can't make a straight line over. Yeah, better at least. So these are the two products, water and ammonium nitrate. So the name of this compound is going to be ammonium nitrate. NH4 means ammonium and NO3 means nitrate. So it is going to be ammonium nitrate over here. So in neutralization, what we know is an acid reacts with an alkali to give you water for sure and a salt. Acid gives you H plus ion, the alkali gives you OH minus ion, but obviously acid is not H plus only, it has a negative part as well, so let's call it the negative part. Alkali obviously has not only OH but also a positive part, so let's call it the positive part, P plus, let's call it P plus. The H and OH combine to give you the water, while the P and the X will give you the salt. So P is the plus part, X is the minus part, they give you a salt depending on what kind of acid and what kind of alkali you are using. So you can see that H and OH are always combining with each other, making water molecules, and you know the metallic part and the non-metallic part from the acids and alkali combine to give you the salt. And it totally depends on what kind of acid and what kind of alkali you're using. So at the end of the day, what kind of salt you get is totally dependent on the acid and the alkali. ठीक है जी. So we are done with the idea that bases neutralize acids. They can be alkalis which are water soluble, which are only 4 alkalis: LiOH, NaOH, KOH, and obviously NH4OH. And generally the other bases are insoluble ones, which are metal oxides. So in the next session, we'll be talking about the reaction of acids with metallic oxides, and we'll get done with it. So we'll jump onto the bases.